Day two of Q's. Hopefully you watched that video from last week. I did give you some files, not right away. I should have given you files to play around with if you wanted to. That was my mistake. They are on D2L. So if I quickly jump over to D2L, I don't get what I'm looking for. Hang on. Stop. Da, da, da. Let me fix something real quick here. Zoom, share here. If you watched the video, you saw early on we talked about what queues are doing, how they work, very similar to a stack, except the adding and deleting are at different locations. And this was a problem that was part of the video to watch. Uh, and then at the end, it was, can you, after looking at an algorithm, go in and fix what's missing? Like this one was for the arrays. Could you fix the NQ and DQ inside of here to make it work? And up here, could you have fixed the NQ to get this one work, the linked list version of a queue? Okay, so then you would have files, even though you have them down here. It's a matter of practicing whether you could have done it in a small group or not. But stacks, if I'm an expert at stacks, I remember the last one in is the first one out. I'm coming up here to an array. And if I'm adding something at this spot, I pushed it to that spot and then I popped it from that spot. And correct me if I'm wrong, but I needed some sort of num count, something to keep track of how many items that were in there. I pushed to the front, excuse me, to the end, and I popped at the end. And we've had some work with stacks. Your last program was pretty easy overall because you were already given the implementation specification files. When it came to arrays, I didn't go to the end. I added something new in the beginning. And I had to do that first, then point to head. So here, when I pushed in the beginning. And then when I got ready to pop, I popped from the beginning. So with stacks, they were both the same. Last one in is first one out. That means as soon as I put it in, I might be taking it right back out. With arrays, we went to the end. With linked list, we did it at the beginning. And again, we had to do this pointer followed by that pointer. Then queues came along. And this time it was the first one in and the first one out. Instead of push and pop, what words, what function names did we get from last week?
Is it front and back?
No. How did I add something to a queue?
Q and DQ?
Yeah, NQ and DQ. These are my new pops and pushes, but instead they're called NQ and DQ. This time the first one out was, excuse me, the first in is the first out. So if I took a look at this guy and when I get ready, the first one in is the first one out. Well, if I keep adding, I'm going to add to the end. I added to the end, but when I deleted from the front. Oh, 1, 2, 3, 5. If I add 7, it goes there. If I delete, it was 1. So these are now opposites. Oh boy, what happens if I add a bunch and delete a bunch with an array? What was the solution? What was the solution? I add 8, I add 9, I delete 2, I delete 3, I delete 5, I go to NQ41. What was my solution?
Wrap around to the start of the
Yeah,
array.
41 would go here. So I needed a beginning location. I needed an end location. I had that circular idea. I had to do that whole wraparound. Still could run out of memory, but this guy sort of grew and moved. Let's see. The first one in is the first one out. Tell me about a linked list. When I NQ, where do I add something new? Where do I delete it from? Is it the same?
Would
Where did I
you
add something
into
new? Carl, where did I add something new?
you add it, I guess, at the end.
Add it at the end? And he said, I guess. What if I have 9,000 items? Is that easy to work with?
No.
No. What's the solutions here? The first one in is the first one out. Anybody? Well, then let's walk through it. How would I add to the end? Would I have to go through the whole thing? No, maybe.
Well,
Or
wouldn't you just create like a front and an end and then set your value there?
how about a rear pointer? If I have a rear pointer and I want to add something, I would go to rear pointer. Rear pointer's pointer would go to new node. If I want to delete, I would delete from the beginning because that would have been the first one out. So let me ask you this. Did that work watching the video? Doesn't sound very promising. Some of the video you saw looked like all of this. How did we do all this? Oh boy, if I had a list and I wanted to add something, I had rear pointer and I would add right here with rear pointer. If I wanted to delete something, I set a temporary pointer. Instead of head, we're calling this front. And then I would send front over, and then I could get rid of temp pointer. I could destroy it. Check if it's empty. If it's empty, front gets new node, rear pointer gets new node. Otherwise, rear pointer's next points to new node, rear pointer equals new node. So in the video, there's plenty of drawing and stuff going on here. How do I delete from the front? Temp pointer gets the value of front. front points to its next. I grab the value from temp pointer because I'm pulling the value out of there, and then I destroy that temp pointer to free up memory. Kind of feeling like I might have questions. Again, here stacks, push to the end of the array, pop from the end of the array. Linked list, push at the beginning, pop at the beginning. A queue, first one in the line is the first one out. One of the things that was talked about in the video is if I deleted something, do I have to shift all the elements to the left? The answer was no. I kept track of a location. Front is 0, rear is 0. Start them out at -1. When I enter something, there was an A there at one point. The front was 0, the rear was 0. I entered B, slowly the rear moved, right? We got to the end, it was full. I start knocking things out. Okay. Did anybody else show up? I think so. Yes, everybody's here. Let me go back to here, and going to jump over to D2L and get back to Zoom so I can share what's on D2L. And what I'm going to do is break you up into two groups. Today we'll be using groups and and you have to figure out how to do this as a group. You have no program this week, but this is in lieu of your program. You're doing a group project and trying to get it work before the end of class today to get full credit. So this is an in-class assignment. You have to save the patient, right? You can't fix the arm and the leg and not the heart, and the patient dies. So by the end, and then an hour later, oh, we fixed the heart. Too late. All right, you will be working in a friendly farm or grocery store. Names are important to customer service. The owner wants to keep track of the names of the people as they get into the line. So we're going to have a line and we're going to keep track of people as they come in. All right. You need somebody that's going to be in your group, which is going to be half the class, to kind of be in charge. Okay. You are going to work with the dynamic queue, dynamic being the linked list one. As you see down below, I've included the demo or the driver program and the specification program. All you have to do is get this program up and working. So what are you going to see? You're going to see a menu. You're just going to name of the person in the front of the line, name of the person at the end of the line, how many people are in line, add a person to the queue, remove a person from the queue, remove a specific name from the queue, display everyone in the queue, terminate the program. So let's take a look at the two files. The first one is Zoom. Give me 1 second. Share. The first one is what you see. Oh, line 8, system color 70, changes color. I don't need to. This is done for you. I've already written this program. If we were a class of 8, I may not have written this because you could have had somebody else write it, but we're cutting it to two groups of 5. Welcome to Friendly Farmers Market. To add a new customer name, blah, 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 a little bit of use of tabs. Enter the customer. Z is 1. We have to make sure NQ is working. DQ is working. Now, I don't want you to go find these and cut and paste. That doesn't exercise your brain to get you to learn these concepts. Chat GPT and GitHub and all those are not your friend. And if I catch you, as you know, I will kick people out of class with a zero tolerance policy. It's not worth it. So here is your driver program that displays a menu and does what you need. The next thing is going to be the, can you all see this header file? Can you see it?
Yes.
Thank you. And inside of here, you see we have the front of the queue, the rear of the queue. We have two pointers created in lines 17 and 18. Actually keeping track of the number of items. That's probably a good thing. What do we come in? And we have one constructor and a whole bunch of methods. Now, how are you going to do this? Well, you're going to have somebody in charge, and that somebody may already have these files loaded up and start by dictating and say like, hey, I'm just going by names I see. Daniel, I want you to do the front line, da da da. So and so, I want you to do the front, the is full, somebody the back line, and then sort of have two people maybe building the implementation file. And then as pieces get done, you can paste them in the discussion board. You can go and use our discussion board on D2L to put the code to help you cut and paste it. You can use the whiteboard if you have to draw because you don't understand something. But I need you to finish this program for me today. Joe Bob and Billy Joe were working on it, but I fired them. So you have to finish it for them. Yeah. Okay. So I'm going to make two groups, and then you have to show me the patient lives before the end of class. 55 minutes to get this program. So divide and conquer. A leader step up. No dictators, no freeloaders. Capiche? Capiche, man, it says. All right.